Hi, my name's Cameron, and today I'm going to do a presentation on the power of the cloud. This presentation is for SIS 4010 Cloud Computing. The goal of the project is to create a command line interface that allows users to create profiles using facial biometrics. The user can store information such as names, descriptions, interests in their profile, and later on can be retrieved using a face via facial recognition. Our hopes is that this program will demonstrate the full range of possibilities that the cloud computing offers us. Our program encompasses three cloud systems: Azure's Cognitive Services, Heroku's Dino Services, and MLab's MongoDB database. These services are all used by a command line interface that was written in JavaScript, Node.js. Within the interface, a user can create other users, update their information, and detect a user from an image that is provided. So the first cloud aspect is Azure's Cognitive Services. So we use them for our facial recognition. They have a free tier that allows 20 transactions per minute, which is adequate for our needs. And they provide an API that is straightforward and make it very easy to use our service. There's different ways to interact with cognitive services. However, we mostly use two actions: register a user and detect a user. So the flow to register a new user, there's three API endpoints that you need. The first one is the /persons. This creates a user and stores it within Azure's abstracted database. So we don't see this database, they manage that. The first thing you need to do is post to that endpoint, and within the body provide the user's name, and it returns a person ID. So this is the ID of this new user. The next step is to add faces to this new user with this person. So to do this, you use a persisted faces endpoint, and it accepts in the body a URL of the image. So this is if the image is already on the internet, or a binary stream. We use this option because the image lives locally on our computer. After these two endpoints, you need to call train to train the data set. This is relatively fast, especially if you're just using a few images for one person. The next action we use is to detect the user within an image. So the first step to this is to call the detect API and provide a URL or binary stream of an image. And this will detect if there's a face in the image. If it is a face, it will return a face ID. And then you take this face ID and you send it to identify. And if the system recognizes this face, it'll return a person ID. And also returns a confidence percentage to show how confident it is about that face. So these are two actions that makes our program. They're very powerful but very simple. The next cloud aspect is Heroku backend hosting, which uses the Dinos product. Heroku is a smaller player in the cloud industry. However, they do provide straightforward ways to host many types of applications. As I said, we use the Dinos service to deploy our Express.js backend with a RESTful API component. They provide a deployment option using Git, which makes it straightforward and easy for us to use. It only requires a few steps. The first step is to make an account, and then on the dashboard of Heroku, create a new application. This creates a new Git repository that Heroku has, and they provide the remote URL for it. And then on your local machine, on your local Git project, you just add that as a remote. And then when you're ready to deploy, you push to its master branch. So it's already using stuff we already know, Git commands, simple Git commands, and takes care of all the deployment behind Git and behind Heroku, making it very simple. The last cloud aspect is MLab's MongoDB database. It's pretty simple. It's just a Mongo hosted DB that uses Mongo. It has a few tiers that you can use. There's a free tier that provides adequate storage for small projects like this. And it's very easy to make an account. You just go online, you give a name for the database, and that's it, because Mongo is schemaless. And then it provides you a connection URL that you can use to connect to it within your backend, like any other database. So our major accomplishment is that we took 3 different cloud services, cognitive services, Heroku Dynos, and MLab's database, and we combined them together so that a command line interface could use them. For security, cognitive services in our database is connected through our backend, and the CLI only talks to our ExpressJS backend through a RESTful API. We did this just to follow general practices of not exposing your database and your private keys on a client's computer, because the CLI will be on their computer. So that is our major accomplishment. This was set up relatively quickly compared to if you're gonna do it yourself. There was no need to set up a local server and port forward the ports to make it publicly available on the internet. There's no need to mess with any configurations. A lot of the technical and configurations part were taken care for us by those providers, and that we believe that the combination of these 3 components really shows the power of the cloud. So here's a demo that we're going to run through. There's 3 images we have of Hugh Jackman, the actor. So I'm just showing these 3 images. So I'm gonna first create the user using the first image of Hugh Jackman. So Hugh Jackman.jpg. So I give it a name, Hugh Jackman, the file name. So this step is using the first step, the first flow of creating a user, calling those API endpoints that we looked at before. So it returns a person ID. And the only time we need this person ID is for the next step, which is adding more more trained images. So I'm now going to send Hugh Jackman to .jpg. Give the person ID in a new image. And now Hugh Jackman's datasets have been trained, now has 2 images. There's always good to have more than 1 image because there's different angles and different colors between images. Now I'm going to actually look up a user with an image that the system hasn't seen yet. So Hugh Jackman 3. So you see this image is slightly different, different coloring, different light, different angle. So the system has not seen this image yet. So I can do Hugh Jackman 3.jpg. And it recognizes as Hugh Jackman. So the next options I'm going to show are 4 and 5 that uses our MongoDB database. So now I need to provide an image. Now we don't need a person ID, so we just need an image. So I'll do Hugh Jackman 3. So updating Hugh Jackman, so it recognizes that it's him. Now the information is just a key value system. Now the information has been stored successfully. Now we can retrieve it pretty much the same way than option 2. You give an image. We're going to give Hugh Jackman 3 again, and it's going to return their information. So that's our brief demo of the application. However, you can see that these can be expanded more, and especially if it's beyond CLI, it can be very powerful. For future work, so if anyone wants to get involved and use these resources and tools that we used for this project, here are the links and resources. I do recommend using the first two, MLab and Heroku. This is because they're extremely easy to set up and use. There's a very small learning curve, pretty much non-existent. You can get set up very quickly. And their free tier are very adequate for small projects, schoolwork, and even side projects for fun. So here's are the two links for that. If you're doing anything with facial recognition, I do recommend Contiv services. Other service providers have other ones like AWS and even Google Cloud. But the experience I had with Azure's Contiv services was very positive. So I do recommend if you need to do anything like that, check them out. There's that link. Even without a student account, they do provide a free tier that was discussed earlier. So if we had to do this again, and if we had more time, unfortunately, for this final project and presentation, I was the only person that was able to do this. So I did this solo. So I had a bit less time. We're initially planning to use instead of a command line interface, we want to do a hosted website that would have been probably written in React, and then could have been hosted with Heroku or even S3. You can host single page apps with them. So if we had to do it again, we had more time, definitely use a website. And then if we had even more time to optimize that website for mobile or even make a mobile app, to be able to use the front and rear facing camera, because that would have really opened up more opportunities. So these are two major things we had done, and other things we had just add more features, but I believe that these two would have been our top priority. So this is our presentation. Thank you for listening. I do really recommend looking at those links we provide. The cloud does provide a lot of opportunities to expand small projects for very little cost or even no cost. So thank you for listening, and have a great day.